Hey guys, it's Miss Adams, and we're continuing the Unit 12 test review. We're on page 3 now, so problem 8. We're looking at another two-way frequency table here, but now we're going to be looking at some percentages. So it says the table below represents the beverage choices of 20 children at a daycare. The first question says, what is the percent of the boys that had milk? So I first got to look at the total number of boys, which is 6. And then I'm going to look at how many of those had milk. There were 4 boys who had milk. So I'm going to take 4 divided by 6 and multiply it by 100 to get my percent here. And that's going to give us approximately 66.7%. So I'm just going to round to the nearest tenth. Our next problem says, what is the percent of the girls that had juice? So I know I had a total of 14 girls. And I know that 8 of those girls had juice. So I'm going to do 8 divided by 14 and multiply it by 100. I apologize. Looking at juice, not milk. So 6 of those girls had juice. So 6 divided by 14 multiplied by 100. So that's 42.9% approximately. Now we need to read C and D pretty carefully, because C says what percent of the children that chose juice were boys. So I'm trying to figure out how many of those children chose juice. Well, I know a total of 8 children chose juice. And I know that 2 of those children were boys. So 2 divided by 8 is going to give us 0.25. Multiplied by 100 is 25%. But then the next one says, what percent of the children were boys that drank milk? So I'm going to use 20, so my grand total, as my denominator. And now I'm going to see how many boys chose milk. Well, I know 4 boys chose milk. So 4 divided by 20 is going to give me 0.2 times 100 is 20% of the children were boys that drank milk. Now, I know it skips problem 9, but problem 10 says label each scatter plot as either linear, quadratic, or exponential. So we're going to look at some trends here. This first one has a pretty linear trend because I can draw a pretty straight line through that data. So I'm going to say that the first one is linear. The second one, we've got kind of a plateau and then a curve. So this is exponential. The third one has a parabolic shape to it, so it's got that U to it, that character to U for a parabola, which is going to be quadratic. And then the last data set, also, I can form pretty much a line here, so this is a linear set of data. Now, problem 11, we're going to be organizing these given scatter plots by their R value. So we're going to place the letters for each graph in ascending R value from -1 to +1. So remember, -1 is granted, these are not, none of these are exactly perfect, but we're trying to get them as close to these given ranges here. So -1 means that it is a perfect negative. So I would say that C has a perfect negative trend. So as X increases, Y decreases. Now, I want to look at a trend that is, let's go ahead and go to the next extreme, which is going to be a perfect positive trend. So as X increases, Y increases. So that would be our D value. And then I know if I have a correlation coefficient that is 0, that there is no trend. And in my opinion, that is going to be A, because there's no definite negative or positive values here, which leaves B and E. So B does have a positive trend, but our scatter is a little bit more spread out. So I'm going to say that positive 0.5 correlates with our scatter plot B. That leaves us with that negative 0.5 scatter plot correlating to scatter plot E. So that negative 0.5 correlation coefficient is going to correlate to scatter plot E. And guys, that's everything from page 3. Let's go ahead and move on to page 4 because we only got 3 more questions left for this Unit 12 review. So on page 4, it says Eurydia ran an experiment where she varied how much sleep she got before big test to see how it would affect her test scores. The scatter plot shows the hours of sleep she got and the score on a test that he took the next days, or that she took the next days in tens. So we have our X values, which is the hours of sleep, and our Y values, which is the scores on the test. So I want us to just go ahead and look at that scatter plot first. We notice that it does have, if I were to just draw a line of best fit through this, we have a positive trend here. So as X increases, Y is also increasing. But we can actually find these exact values using the calculator. So I'm going to put in the hours of sleep in my list 1. So I've got 1, 1, 2, 2, 3, 4, 5, 5, 6, 6, 7, 8, 9, 10, and 10. So that's 15 list items. I'm going to go press the right button and go over to my list 2. Remember, these are the scores on the test by tens. So I've got 1, 1.5, 2, 3, 3.5, 4, 4, 5, 5.5, 6, 6.5, 8, 7, 6.5, and 8. I'm now going to hit second data and go to the 2 variable statistics, where my X data is list 1, Y data is list 2, and I only want a frequency of 1. Then we're going to scroll down until we see A, B, and R. So that's going to be your D, E, and F choices. But I see that A is equal to 0.696. So I'm going to go ahead and just round that to 0.7. B is equal to 1.1. And my R value in this case is equal to 0.95. So if I'm creating a line of best fit here, I can say that Y equals 0.7x plus 1.1, because my line of best fit is Y equals AX plus B, where A is your slope and B is your Y-intercept. I now have a correlation coefficient at 0.95. This is a positive correlation, and it is very strong. It's above that 0.8 threshold. So what test score would Eurydia get if she slept for 8 hours according to your test for the line of best fit? So now I'm going to go ahead and say Y equals 0.7, but where I have my X value, I'm going to substitute that. Excuse me there, guys. With a value of 8 plus 1.1. So I've got 0.7 times 8 plus 1.1 gives me 6.7. But remember, these are test scores by tens. So I'm going to go ahead and multiply that by 10, which is going to give me a test score of 67. So if she slept for 8 hours, then she got approximately 67 on the test. All right, let's look at the next problem. This one should be a pretty easy problem. So we're trying to define the shape here as either bimodal, unimodal, or uniform. Bimodal having 2 modes, unimodal having 1 mode, and uniform having 0 modes. So this first data set, we've got 1 mode here, which means it's going to be unimodal. The second data set, we've got 2 modes, which is going to be bimodal. And the third data set has 0 modes, so it is uniform. Our last question is going to be correlation versus causation. And guys, these can get a little picky, but just stick with me here. So remember, a correlation just means 2 things were co-related. They occurred at the same time. Causation is a cause and effect. So you lied to your parents and now you're grounded. You created an action. There is now an effect to your action. This is a causation. The number of hours you worked and money made, guys, this is a correlation. These 2 things are correlated, but not always caused. And well, actually, I take that back, because number of hours worked and the money made, it depends on if you're paid by the hour or not. We're going to assume that you're paid by the hour, so I'm going to call this a causation, because it is a cause and effect. As a child's weight increases, so does her height. This is not always true, so this is a correlation. The temperature outside and the number of people selling ice cream. Granted, we do see a higher occurrence of this, but once again, just because the temperature increases does not automatically mean people are going to sell more ice cream. So this is a correlation. And then Becca noticed that more people went to the grocery store on Mondays versus Fridays. There is no reasoning here. There is no cause that is creating an effect. So this is a correlation. All right, guys, that is everything for the Unit 12 test review. Good luck.